In this section, we're going to extract the rail ballast using the existing rail lines and repurposing the road extraction tool. The settings for the road extraction tool are going to be fairly similar to how you'd use it on a road, with a few differences. First, set your width to what your maximum desired terrain extraction will be. This can go beyond any break lines that you may have. Use the key point setting and set the parameter to the maximum distance you wish to have between extracted points and the data. You're going to select a rail or center line as your guideline. This tool can only find terrain breaks, not hard breaks such as curbs. Therefore, you can limit the extent of what this tool extracts by setting boundary levels. A boundary level can be an existing break line that you've extracted in 3D, or it can be as simple as drawing a line from top view, which you don't have to set any Z values for. Some of the key differences in the options are going to be that you must adjust the noise tolerance so that it fits the width of the terrain noise. This is going to be a lot higher than you would typically find on a flat surface such as concrete or pavement. You also must make sure that the slope tolerance is high enough to accommodate for any dips or inclines that you may find on the terrain. The tool will stop looking above the offset you have in the height limit. Therefore, if your terrain is sloping upwards, you want to make sure that you have a high enough height limit to accommodate this. Whenever you're extracting terrain, always have use less smoothing checked. On this dataset, I have two sets of rails, so I'm going to create a center line between the two rails and use that as my guideline to extract the ballast. Now I'm going to open my road extraction tool, set my left and right parameters to the maximum that I want them to extend from the center line. Also, I'm going to set my step to 3 and my plot key points to 0.03 of a meter. Set my boundary levels to all the curbing that I've already have placed beforehand. And I have a few temporary lines to act as boundaries as well. In view 2, I can see the cross section of the data that the tool will be looking at. I need to make sure that my noise tolerance is set to the width of the terrain data noise. Before running the tool across the entire guideline, it's a good idea to test it by clicking the Section button. This runs the tool only on the cross section that you have currently selected. As we can see, the tool can find the terrain breaks, but it's not going to find a hard break such as a curb. And that's why we need to make use of boundary levels. I'm going to change my level I'm drawing in to one that I already have selected in my tool under boundaries. Because I don't need to worry about the Z coordinates of my element, I can draw it from top view. You may notice that the rails themselves trigger breaks in the terrain when you don't want them to. We can solve this by classifying the data around the rail by creating a shape that fits the rail data inside of it, and then using the existing rail line to classify the data inside the shape along the rail element path. I'm changing my display to classification mode so you can see how it's going to change. Some of this data is already classified, but you don't have to worry about that. Go to the Envelope Along Path tool within the Classification tab. Select the shape, select the rail path, and classify to the layer that you want to. You can see the rail data is now classified in red. With this data on, it sets off a terrain break line. But when you turn it off and you run the tool, there is no more break line there. Now that I'm satisfied with my settings, my boundaries, and my rail data has been classified and I can hide it when I run my tools, I'm going to select Auto across my center line guideline, and it will run this tool at the step distance I set, in this case, every 3 meters. You can view each cross section by selecting the guideline and then clicking Move up and down within the tool. Within View 2, you can see each cross section and how it extracted it.